Oh, very quick this time, a very short video. Review what we have learned before. A simple chemical cell. It's made of two different metal with different reactivity and some electrolyte which contain mobile ions like hydrogen ion and sulfate ion which can conduct electricity so that the circuit will be complete. Okay, and then for the more reactive metal will be the negative electrode because Mg will lose its electron and become metal ion, so the electron will flow from Mg to copper. And when electron flows to copper, then there will be a lot of electron accumulates in copper electrode. So the ions with positive charge, which is hydrogen ion, will be attracted to the copper, and then they will gain electron because in sulfuric acid, hydrogen ion is the only ion with positive charge, and you cannot find copper 2 ion. You cannot find copper 2 ion in dilute sulfuric acid. So here the ion accepting electron is not copper, it's hydrogen ion. Most of you in the homework you give me, you wrote copper 2 ion gain electron, but in sulfuric acid there's no copper ion, only hydrogen ion has the positive charge. So it should be positive ion accepting electron and become hydrogen gas. But this battery is very inefficient. Why? There are two problems for this kind of cells. The first problem, you can look at the negative electrode, Mg. Mg, reactive metal. What will happen if you put Mg into sulfuric acid? I think most of you know it. Mg will dissolve and will react with sulfuric acid quickly and forming hydrogen gas, right? So Mg will dissolve very quickly. If it dissolves quickly, that means the battery will die quickly. That means you need to change the magnesium electrode very frequently. So it's not a good battery, okay? So the first problem is the metal, the reactive metal may react with sulfuric acid. And then the second problem is, do you know what these are? These gas bubble. Okay, these are hydrogen gas. And can you tell me, gas, is it a good electricity conductor? Of course no, common sense, right? If gas can conduct electricity, then all of us died already because we don't need to touch the socket and the electricity will pass to our body through the air. So this one is an insulator of electricity. So what's the problem? Electricity. Okay, and then the second problem is hydrogen gas is generated or produced on both electrodes, and the gas is an insulator of electricity, so the voltage will be low because it's an insulator, because it does not conduct electricity. So the hydrogen gas surrounding the electrode will prevent the ions being attracted to the electrode. So the voltage will be very low. Okay, that's why we said it's not a good battery. To improve this, the people are people design another kind of battery with 2 half cells, because they found that the hydrogen gas is formed, so they change. They don't use the acid. Instead of using the acid, they use some other ionic compounds. For example, in this one, this kind of cell we also call it galvanic cell or voltaic cell. Okay, so for the copper one, what kind of electrolyte can we use to avoid hydrogen ion? This time we don't use hydrogen ion, we use metal ion. For example, we use copper 2 sulfate solution. Then inside the solution, the cation will be hydrogen ion comes from water. There will still be hydrogen ion, it comes from water, but besides hydrogen ion, there are also copper 2 plus ion, and then this one comes from copper 2 sulfate. Okay, I hope that you still remember ECS, H plus and Cu2 plus, which one is lower and which one has higher tendency to gain electron. If you forget, go and check ECS now. Okay, so this one will has higher has higher tendency to gain electron. This one is a stronger oxidizing agent. Okay, so we use copper 2 sulfate solution instead of acid to avoid forming hydrogen, because after when we change to copper 2 sulfate, in copper electrode, the half reaction taking place now is copper 2 plus gaining electron. Okay, so you complete it, so no more hydrogen gas will be formed. Okay, for another half cell, magnesium, this time can we use copper 2 sulfate solution? Can we use this? The answer is no. Why? A reactive metal, a less reactive metal, which is ion, then displacement reaction will take place. Then the magnesium will also dissolve very quickly. So this time we cannot use the same electrolyte. To avoid displacement reaction, we use the same metal ion. We use magnesium ion. Okay, because now both of them are magnesium, so no displacement reaction will take place. And in the oh sorry, my bad, it should be zinc. Okay, my bad. Okay, so for the half cell involving zinc electrode, zinc will lose its electron to form zinc ion. Okay, for other parts of this table, you should be able to complete it. And but however, if you measure like this, if you use this one, the voltage will be 0. You need something else. You need something else to make the battery so that the voltage will not be 0, will be higher than 0. We need one more thing, which we called salt bridge. What is salt bridge? It's a filter paper strip soaked in ionic compound. For example, we soak it into saturated NaCl solution. Okay, NaCl solution. Saturated, that means the solution cannot dissolve more sodium chloride at certain temperature. That means it contains a lot of sodium chloride. Okay, then why do we use this one? Because it contains sodium ion and chloride ion. But for the function, for the detailed function of salt bridge, I hope that you can find the answer and the explanation in another video that I posted the link to Google Classroom. Okay, so I hope that you can complete. So your task is to complete this table and complete the function of salt bridge here, and by referring to this simple chemical cell using a magnesium and copper as electrode, and using this saturated KCl as electrolyte as the electrolyte in salt bridge, fill in this table. Okay, in the left half cell, ions that move from electrolyte to salt bridge, that means the ions move from the electrolyte to salt bridge, which one? Okay, and the opposites, the ions move from salt bridge to the electrolyte, will be which one? Okay, also the same for the the half cell on the right hand side. And number 4, you also need to fill in how to prepare a salt bridge. As I said, soak a strip of filter paper into an electrolyte, and the electrolyte should be an ionic compound which has mobile ion, and the electrolyte should not have reaction with the electrodes and the electrolyte. That means it should not have reaction with anything inside the simple chemical cell. So your task is watch the following 2 videos from YouTube and complete these 2 pages. Okay, page 12 to